actually doing and what is expected here. Okay, everyone is from network background, so it will be easy for me to start from scratch. So recording has started. This will be our today's first class. Everyone knows that we are having systems, PCs, multiple PCs. So we have two environment. One is data center environment and one is corporate environment, correct? So there is a boundary. There are two types of engineers. One works with legacy, not legacy. One will works with the data center environment, and one works with the enterprise environment. In enterprise environment, what would happen? The PCs will be there. Those will be connected to a first layer of switch. The switch is called as access layer, correct? Then they all will get connected to a distribution layer. After that, there would be a core layer, and they all are connected, interconnected like this. True? Everyone is there with me?
Yes, sir.
Yes.
Okay. So this is how the
Yes, sir.
okay, this is how the enterprise networking is set up. And after that, we have two paths. After that, we have two paths. One is internet, another one is MPLS. One more guy is calling. I think I have not added it. 1 minute. Yeah, one more eighth guy is also there. So he is not able to join today. That's the reason he called. But if you give thumbs up on the voting itself, so I'll come to know that you are not joining. Okay. So here, how the internet traffic will go from core, it will be handed over to internet, and again how the internet traffic will go, it will be handed over to MPLS. Correct. And then through MPLS, it will connect to the other part of your environment, site A, site B, site C. Same way, if it goes to internet, then it will go to the public world and connectivity will be addressed if you're accessing to Google and all these things. Inside of this, you can also add firewalls. Okay, you can add firewall as well. So you can do the rerouting of your traffic. If any traffic comes in, then you can route it through firewall and then take it back and then route it. So this is called as firewall. Load balancer will be there in enterprise network. Any idea? Pradeep?
Hi, sir. I'm working currently on data center right now.
Okay, so do you think
Involved.
the enterprise environment load balancer would be there?
S- Sir, I think the enterprise network doesn't have load
Load
balancer
balancer.
because
Yeah.
they don't have any servers like public applications and all things or public database. So that's why I think.
So why it's not there? Because enterprise doesn't require any servers. Okay, they are consuming servers, but they are not hosting the servers. So where servers are placed? Right side, data center.
Yes.
So what kind of servers those would be? Any idea, guys?
Uh,
Some,
Database and authentication and all kind of service.
okay, I'll name it as AD, then DNS, FTP, DSCP. Okay, all these servers are there in data center environment. Obviously, that would be connected to a switch. The same way we are connecting, so that would be access switch. Okay, and then it will have a distribution layer or no, or directly this will be a core layer. Pradeep, in data center, whatever they will wherever they will connect, that will be generally core switch only, or it's all up to you, collapse core or access or distribution like this. It's all up to you. So directly server would connect to a switch which will do the routing. Okay.
Yeah,
Or
exactly. Then leaf switch.
no, so the leaf switch I am going to introduce after this. Okay.
Okay.
So now we'll introduce Nexus switches. So Nexus switches are directly L3, right? Directly servers would be connected to their top of the rack switch, and then the top of the rack switch will connect to Nexus for routing and switching. Okay, so connectivity will come to the Nexus switches, and the Nexus switches, this server will form the redundancy. Okay, so they have VPC here. So this VPC will have the two upstream devices, but they are treated as the single device, whereas this technology is not available in enterprise because we are not investing that much in enterprise. However, we are investing more in data center. So here you will have Nexus, for example, or if you are Juniper, then other variant of switches. Then you are connecting like this. After that, you are also having firewalls. Correct? You'll have firewall. Connectivity will go to your firewall, or sometimes the firewall will also host as a gateway in data centers. So this will hand over the traffic here. Then you will also have the load balancers. Okay, so what will happen, the load balancer will also be there, and then you will have something other kind of switches and all, but I'm not going to draw all the picture. So then you will also have same will be connected to not directly this device. You'll have some other variants of switches and all, and then you'll be connected to your internet and MPLS, but directly I am terminating this to internet and MPLS. Correct? So if anyone wants to communicate to the server, then they will access the load balancer. Then before this firewall will be there, but let's treat it as a firewall. That will be a wrong design. Okay, first firewall will be there, and then you'll have load balancer. Load balancer will go ahead and distribute the traffic. Okay, so this is how the data center design would be. Correct? Now technology has improved, and now we got something like ACI in picture. Okay, what ACI is doing to same set of servers. Okay, same set of server, ACI is having something leaf and spine and leaf architecture. Okay, so there would be two spine. Okay, and multiple leaf switches are there, and these leaf switches are in connecting to downstream. They are called as the leaf switches, and these are the spine switches. Okay, spine will not connect to each other, however they will connect to their downstream leaf switches. Okay, how they are connecting? They are using ISIS protocol. Okay, and automatically they are identifying with each other, and they also have here one sort of server that is called as the controller manager or epic server. Okay, so this is called the software defined networking design. So this epic server, by sitting here, this server is going to handle all the ports which are going downstream towards your servers. Okay, so you are not directly going and logging on to the switch, however you are logging into epic, and from here you are instructing all these ports to work on. So this is policy driven. Okay, earlier what happened, if we have to do any changes here, then we have to go ahead and take a SSH of this one, and then we'll modify this port, and then this will act as, if you want to shut down this port, you will shut down. If you want to make it trunk access, then you can do it. But the question is, you have to log in through SSH, and then you have to do it. But the same thing is not here. You have to log on to one central device, okay, control device, and this controller or management plane device, you have to log in, and from here you are going to drive your whole environment, no matter if you have 2 leaf switches or 10 leaf switches. Okay, so this is how the environment is working as of now. So this side is called as software defined networking. Okay, so what is the mean of software defined networking? Here if you see, these are the legacy environment, this enterprise and this data center, first and second, these are the legacy data center environment where you are having generally devices where individually you have to log in. Okay, whenever it comes to individually, If someone fails, then along with this, the management configuration also fails, the control configuration like OSPF and BGP neighbor, that also fails, and whatever it's having ARP entry or IP routing or anything IP accounting, that also fails. Okay, all three things will fail. Even we have redundancy, traffic will route it through another path. Okay, so these two are considered as a legacy environments. Legacy, this is a legacy data center, and this is the enterprise, but it's still running on legacy because we have only SD-WAN here up till here, and still this is running on legacy. But if you go to this data center environment, this is running as a legacy, but if you want to upgrade to, then you can go to software defined networking. But before going to software defined networking, is this the first time we are going to do it? No, already compute and storage, they both have achieved this one. How? Let me go ahead and explain. They are already done with that. Okay, so this is first time we are doing software defined networking. Already they are done with software defined compute and software defined storage. So what is software defined means? Suppose you are having small servers. Okay, like I'll take example of this one only. First I'm going to explain the compute virtualization, then I'll go to network virtualization. For example, you are having 4 physical servers. Okay, yeah, for example, you are having 4 physical servers. So do you think so all will get utilized 100%, Raju? The first server will get utilized 20%, second server will get utilized 30%. Okay, the FTP will get utilized 60%, and this will get utilized 10%. What do you think? So what we are doing with the remaining hardware? What is hardware? Hardware is nothing but your CPU, RAM. Okay, so what you are doing with CPU and RAM, even including if you include your mobiles. Okay, how many we are here? We are 6 now on call. Okay, so everyone is having minimum 64 GB of RAM. Agree?
Yes. Yes.
Okay, if we are 6, 64 we have. Okay, so for example, suppose we are let's take example of 8, we are having 64 GB of RAM into 8. So how much it would be? 64 into 128, 256, and then something 500 GB of RAM we are having. Okay, do you think we are all are utilizing full RAM? Obviously we are utilizing not more than 35%. So what's happening with our remaining RAM? We don't know. Even including if we are 100, if we have 100 GB of storage, so everyone is having 8 means 800 GB of storage. So how much storage we are you utilizing? Something 40% or 50%? Yeah, Raju, if you are outside, you can mute it. Not an issue. Okay, so suppose you are having storage, and how much it would be? 64 into 8. 64 into 8, 512. Okay, out of 512, if we are utilizing only 300 GB, if we are having 100 GB of storage into, if you 8 mobiles, then where is your and you are utilizing 50% on an average, then where is your 400 GB of storage? Do you have answer to these questions? Obviously no. Those things are unutilized. Do you agree with me, Pradeep?
Yes, sir. Yes, sir.
Yeah. So what happened, the compute guy, they virtualize this environment, and the storage guy, they virtualize this environment. So let's see how they virtualize this. To answer this question, what they did, simply they, instead of having individual physical server, and also there is a problem with physical server, if power fails, then what would happen? You have to have the another, you have to arrange another hardware, and then you have to recover from backup, and then it will take something 5 to 10 hours to recover from backup. That 80 server restoration will take 10 hour or more than that. Even again, if you have any problems, something is not there in spare, then it will take okay, that will be an issue. So in order to address these issue, so what we did, we bought the big servers. So whenever I'm drawing such kind of boxes, compute them, consider them as a servers. Okay, so these servers, now on top of this server, if you are running on top of any device, if you are running operating system, then the whole resource is acquired by your operating system. For example, you are having laptop. On top of your laptop, you are running your Windows operating system. So who is acquiring the full hardware? Who is acquiring that full hardware? Your operating system, correct?
Yes, yes.
If this is the Windows, so Windows server is acquiring the taking full control of it, and Windows is not going to share with any other operating system. If you have a plan to install any other operating system on top of same hardware, is it possible to install Linux on your laptop same time without virtualization? No. Windows will not allow you to use this resource. Okay, you won't be able to use the remaining part on this one. So that's the reason we need someone who will sit between Windows and hardware. So that is called hypervisor. Okay, so in compute, what they did, and why I'm teaching you the compute now, because until and unless if you don't know the compute, you won't be able to understand the networking concept of virtualization. Okay, so here what I'm trying to say here is, if your all the networking components which will get virtualized, they are going to run on top of compute. And if you don't know compute, then obviously you are not going to troubleshoot it. If you are not going to troubleshoot it, then you are not going to get expertise, and you are not going to form your own private cloud. What is private cloud? Private cloud is something which you are driving within your environment. You are hosting in within your environment, that is full in your control. What is public cloud? It's something placed by Amazon or AWS. They are having full control over there, and you are just placing orders. You are not doing anything else. But here in private cloud environment, you have to manage your own compute, you have to manage your own storage, you have to manage your own networking. So you must know the compute before proceeding for the networking. Okay, so here, if I'm going to address this question's answer, that I want to utilize these things, so what I will do is, there is a concept called as hypervisor that will get, this is kind of operating system you can say, and this will get installed on top of your physical server. So whenever it comes to physical server, what are the components are there on physical server? Any idea, Shabib? You'll have RAM.
Hello.
Yeah.
Yes, sir.
So, so in physical server, you'll have RAM, right?
RAM, CPU.
Okay, CPU.
Yeah.
Then,
Hard disks.
okay, hard disk will be there in your hard disk, means full big hard disk or small one?
Storage.
No, there will not be storage on this
There
one.
are plenty of hard drives.
No. Okay. So here there will be a small hard disk that is only sufficient only to install your this operating system. Actual hard disk will be outside. Okay.
Yeah,
So
yes.
you can mute your line, Pradeep. No issue. So you'll have RAM and CPU, and you'll have your network interface card. That's it. You'll have only three components. If you are having graphic cards, then that is the advantage, but you are having these three components only. So where is storage? Generally in your laptop, what you are having? In your laptop, we are having RAM. Okay, then we are also having CPU, and then we are also having a network card, and we are also having storage. But this is not applicable here in server world. In server world, you are only going to have RAM and CPU and network card on your physical drive hardware, and the storage is kept something outside the box. The storage is there here.
There are some servers with storage.
Mhm. So what is the okay? So you mean there are some servers which are having storage? Okay, so let's do one thing. Let's keep some storage here for some time. Okay, then I'll have a scenario where you'll see that why storage is not required within the server. Okay, so obviously the server will have storage, but this server is not to host your servers. The server is for internal small things to hold the operating system. Okay, then once you have these two servers, then on these two server, on top of this, you are going to host your AD server as a virtual machine. Any idea, guys, what is virtual machine? Anyone knows what is virtual machine?
Uh, Guest operating system.
Okay, so where
There-
it get installed?
Uh, in the hypervisor, we create a virtual machine.
On top of hypervisor. So this
Yeah.
is on top of hypervisor I have created, and I also placed it on top of server. Fine, this looks great. Okay, so guys, you are having your physical server, and on top of you this in orange color your services are running: FTP, DSCP, DNS, and AD services. Okay, if what is the benefit of doing this? The benefit here is, if you want, okay, your whatever your consumption was there before, now that is getting utilized. Utilized means, if you think that this server is getting before before they we were utilizing 30%, now you can go ahead and use it 70% or 80%. Okay, if you think that this server is running idle and this service should not be here, then I'll go ahead and place it here. Then the server will run all the four machines. Okay, later you think that now you are having some maintenance work, you want to increase or do some changes in RAM. So what you can do, simply you can go ahead and offload all these three components from here, and then you can put it on this server live without any shutdown and all. Okay, then you can take this server into maintenance, you can replace the RAM, and then you can put these servers back. So this is the good thing about the virtualization. By doing this, your operating system will not get restarted, you'll not lose any connectivity. If you are using this server, then frequently you can go ahead and utilize these services. So with the help of these things, you can go ahead and move these servers away, and then you can move it back on top of this one, these services. Okay, so this is called as compute virtualization, and this is just only introduction. Later I am going to cover it in detail. Okay, so this is how compute virtualization is there. But if you hold these all operating system, all these servers inside of this storage, then what would happen if all of a sudden this server failed? Okay, if this server fails, then what would happen? You lose all these things. Got my point? If server got failed, then obviously hard disk is there inside of that server. Without hard disk, you won't be able to boot it on another server. So the best idea here is to, instead of using this storage, let's use this storage, external storage. Okay, so your all the operating system data is stored in external hard drive. If this server fails, if due to some reason if this server fails, then what they are going to do, we are going to restart these to different server. This is called as high availability HA, with the help of this hard disk. What you need a hard disk, you need your data, right? You need your operating system to restart. So with the help of hard disk, you can go ahead and restart it on another server if this server fails. Got my point? That's the reason we need external storage. Any question, guys? Okay. So now the big question is, if virtual machines are there, then we should have virtual switches as well. Correct? So for your information, now you are going to have virtual switches, virtual routers, virtual firewall, virtual load balancer, virtual VPN. Okay, everything is getting already, everything got virtual. Okay, virtualized. Generally, we used to have physical routers, right? But now we are having logical routers. You don't have to buy any hardware. Simply you say, I need one hardware, the hardware is play. I need one router, the router is created. Simply you say, I need a firewall, the firewall is created as a virtual machine. Simply you say, I want a load balancer, the load balancer is created. Nowadays, AVI is there, advanced load balancing. What advanced load balancing is there? You don't have to deploy the load balancer. Simply you have to tell that what basic things we need to form the load balancer. Who will tell? Priyanka? We need VIP and pool, right? What configuration we need for
Yeah,
load balancing? VIP and pool. Simply you have to
you'll need,
give the VIP.
yeah,
Yeah. Simply
wait
you have to
pool
give.
and then you'll have pool members of your servers.
Yeah,
Can then
simply you
get
have
the
to give
connectivity.
that information to the controller. The controller will go ahead and deploy the load balancer for you. That is called as advanced load balancer. Okay, so your switches, firewalls, routers, load balancer, everything got virtualized. Even your IPS IDS also got virtualized. Okay, and if still you are working on the legacy environment, then you are far behind this. Okay, so once this virtualization means software defined networking is done, after that, on top of this, there is a thing called as Ansible and Terraform. We call this it as scripting. Okay, I'll explain that later. So here the compute got virtualized and we are having these servers. Earlier these servers were running on top of our hardware. Now they are running again on top of hardware, but they are running not a single server, they are running three at a time. Before, on single hardware, only one server was there, right? But now you are having three servers. So like this, based on your downstream capacity, you can run 10 servers, 20 servers at a time on single physical box, physical server. The RAM would be something 512 GB of RAM or 56 CPUs. Okay, the hard disk will be in TBs. So this way you'll have the physical servers, and these physical servers, on top of this you can run this one. You can add multiple servers live. Okay, and if you want to spin up these virtual machines, simply you can go ahead and spin them then up. This is called as vMotion. This practical you are going to do by yourself, then you will move it here. Okay, first let me have the hypervisor, otherwise you guys will get confused. So whenever you are installing any server, then install hypervisor on top of it. Then simply you can keep moving your server based on maintenance and all. If you want to deploy a new server, new any service, simply go ahead and install it. Say, I want web server, I want application server, I want something else, I want application 1, application 2, TFTP, any server. If you want, you can go ahead and do it. And by default, he is going to do the load balancing. If you are going to place one more VM, then it's going to place it here, because all get divided 333. Okay, so one is big and two are small, then it's going to decide that where to put that. Okay, that is called as DRS. Okay, so DRS will help you to load balance the load among the servers. Okay, and who is going to do it? Automatically it will do it. You have to configure it, and these servers based on load, something what happen, sometime FTP CPU will get increased. Okay, if FTP CPU is getting increased, so your AD performance would be affected, and your AD will not get enough resource. Then AD will simply come and sit here. So this is called as compute virtualization. And who is doing this? This is done by vCenter. So generally I'm talking about VMware only. Why I'm talking about VMware? Because VMware is a big market player in the compute world. So VMware vCenter is the one who is doing this. So VMware vCenter, by sitting here, it will decide who will go ahead and sit where. So this is called as compute virtualization. So you guys are going to have your own ESXi. You guys are going to install the hypervisor. You guys are going to have your own virtual machines. So as soon as we get progress, I'm going to share you the lab. So in that lab, you will go ahead and do it by yourself. Any question, guys? Okay, so this storage also got virtualized, so we don't have to learn the storage technology. Behind the storage, there is no single storage, multiple storages will be there. Even if fails, another will take over. Okay, the storage will be there in form of cluster. If any one storage get fails, then it will get shifted to another one. So that hard disk portion, that is called as LUN. Okay, so that LUN will be here, and you'll buy that LUN, then that will be mapped to your server, and then you'll store somewhere, and then it will be stored there. So that is called as storage virtualization. Okay, storage will have their special switches. They are not TCP kind of switches. They are having their own storage technology. These servers are connected through that port, through fiber optic and all. They are not coming through IP addressing. Okay, it depends. There are multiple kind of storage. SCSI, ISCSI, multiple things are there. NFS, these things are there. So this is called as the compute. So now let's talk about any question, guys, before moving ahead. Feel free to ask your questions. See, until and unless your idea, if you don't clear your idea, then you are not going to get more thing. First, you have to understand that what you are doing as of now and what you are expected to do, and where the world is running. Okay, if you are thinking that by working in enterprise, handling all these things is enough, then that is not enough. If you are thinking that you are working in data center environment where the virtualization and scripting is not there, then that is again not enough. If you are working in software defined networking environment without scripting, then again that is also not enough, because beyond software defined networking, scripting is waiting for you. Okay, so what is scripting? First, let me explain the data software defined networking, then I'll go for that portion. Okay, so this is something enterprise, this is legacy data center, and this is software defined networking data center. Anything, guys? Okay, so I think no question on the data center compute world. I'm going to cover it again back. What is ESXi, how to install a hypervisor, how to create VMs, how to map the storage, how to create the storage. If you have your personal lab, then how you are going to do it, how to install vCenter. First 1 month you are going to do this one only by yourself. Okay, so let's move next. Only 1 minute. Okay, guys, so I'm back now. So let's talk about the software defined networking. Yeah, one more guy is joining. 1 minute. Okay, Imran is joining. Okay, so guys, let's move back to your legacy first. So first we have switch, and then we have router. Then we are having our WAN. Okay, our information access will get connected to this one, and then it's will go for routing. And after that, after once routing is done, then it will take place whether it's going to MPLS or your internet. Okay. If primary path fails, then what we are going to do? Through HSRP, are we going to shift to another path?
Yes.
Okay, correct. But what happens to this configuration? Configuration obviously will have backup. We are having another technology to just to take backups only. HPNA, HPSA. There are multiple technologies which will take backup. Okay. Then if you want to store it, restore this primary path, then what you are going to do? Something went faulty to this router. How much time it would take to restore? Who is working in data center, Pradeep or Shabib?
Sorry, sir.
Yeah. If your primary router fails, then how much time it would take for you to restore if there is a hardware fault? Yeah, you can mute the line. I think there is a background noise, Pradeep. Yeah,
We need
Priyanka, you
to
can
do
ask.
RMA and all kind of things and replace the hardware with new one and bring the configuration on the new hardware.
Okay, so that will take 10 hours or
Yeah,
5 hours.
yeah. We can take 10
No, it
hours
depends on the
or up
service.
to 24 hours to 10 hours. If new hardware is ready, so we can deploy. If not, so we need to order it.
Yeah, every company, see, the company which are running data center, obviously they are having hardwares in spare, but that is going to cost something, right? If you're keeping hardware in spare, then that is not freely available for you. If you're doing RMA, then you have to bear for 10 or 24 hours. Priyanka, you were saying something? Okay, so here you are not going to keep them in spare. So what if I tell you that it will take for in software defined networking, it will take only 10 minutes to restore. Only 10 minutes. And what I tell you that you are going to redeploy it within that 10 minutes. Do you believe that? So first you have to, there is a boundary in between the software defined and hardware defined. Same routers with same functionality. Okay, you will have your switches, you will have your switch. Okay, and you will have your again environment. So the switch will upstream to your routers. If one fails, okay, so we are going to crush this and we are going to replace it with new within 10 minutes. Do you agree with me? But how to do it? That is a question. So that is called as software defined networking. For that reason, first you have to shift from physical to logical. Okay, so that is only with this one. Okay, so in data center, if I am having 100 servers, so what do you think, how many switches I need? We are counting based on ports, right?
Yes.
So we need more switches or no?
Yeah, obviously, if servers are more and devices are more than the expected devices count, so we need to bring the new switches.
So if I have 100 switches, then obviously I had to go for the 48 port module will come, then I have to deploy 3 modules, correct?
Yes.
Yeah, but what I say, if you have 100 switches, 100 same servers, okay, and you will have only 10 to 20 ports, 24 ports are enough, physical ports. That is cost saving or no? Because what I am going to do, I am going to place big servers, okay, and on top of this, I am going to have virtual machines. These will be the big switch servers. They are going to connect to my physical spine and leaf architecture or small means anything. Okay. And here I am going to have the 100 servers as a virtual machine. Do you think virtual machine needs any physical link connection?
No.
No, right? So I'm going to have logical switch. What do you mean by logical switch? Logical switch which n number of ports. This will be a logical switch. You'll see that how I am drawing this diagram, why I am crossing the servers. So this is the distributed method, but I will not confuse you guys. So there will be a switch in each, under each, inside of each server, physical server, there will be a switch. Okay, who is going to configure it? VMware. These virtual machines are going to connect to these switches in their respective VLANs. Okay. And that is n number. You don't have to purchase anything. You don't have to purchase any port. And these only 3 ports are going to bear the traffic, and that it's done. For example, to host the 100 server, I need 10 servers. So multiply 10 servers, you need only 10 ports. How many ports? 10 ports. Take example of I need 20 port. So 20 or 100. You want to go for legacy or software defined networking? Obviously, you will choose this one. Okay. So now there is a problem. What is the problem? There is a hairpinning problem. For example, these are the physical server routers. Who is having VMs in their environment? Anyone? Please raise hand. Fazal, Imran, Pradeep. Do you have virtual machines in your environment? Shabib,
Yes, sir.
do you have virtual machines in your environment? vCenter, VMware, something?
Right now, I'm working on a wireless network, so there are no virtual machines.
Okay.
Previously, they had a virtual machines.
So
We have to
anyone who
manage.
is working? Imran? Yeah.
Actually, I'm not working, but in my environment there is a virtual VM servers are there, and we center we manage. So
Okay.
working.
So for those VMs, what will be the gateway? Who is acting as a gateway? Your physical servers, physical routers?
Yes, physical router will be gateway.
We
Okay.
are having
Physical.
a virtual switch in our
Yeah, yeah.
virtual machines are connected to our virtual switch, which is connected to a physical network card, and the network card is connected to our physical switches.
Physical routers. Then it will come to your physical routers.
Yeah.
Nowadays, we have L3 switches, but for timing, we have to consider them as a router, right? Okay.
Mm-hmm.
So what's happening, guys? These virtual machines are holding their gateway here 10.2 and 10.3. Correct? And they are acting as a 10.1. Who is 10.1? HSRP.
Yes, HSRP or VRRP.
So what is the problem here? Do you think compute got virtualized? Compute got virtualized or not? Because it's hosted on top of one server. And inside of this, we are having virtual machines. So compute got virtualized or not? Compute means server technology got virtualized or not here in this environment.
In
Yeah.
virtual
Yes.
networking side, we can use VSS also
Hmm.
to virtualize our compute in our switches.
What do you want me to use?
VSS.
What is that? VHS.
VSS.
VSS. Oh, VS.
Hello.
I guess lagging is there.
I think
Hello.
voice was break from sir.
Can ping someone.
Yeah, just wait for 1 minute only. Hello, sir. I think sir's meet was struck. So wait.
Hi guys, actually my router got, I have some broadband issue. I shifted to my mobile network. My voice is fine.
Yes. Yes. No.
Yes, sir.
Okay, so here we have light electricity issue since evening, but anyway, we'll continue. Okay, so my screen is shared or
Not
not
sure, sir.
shared yet? Not shared. Okay, so guys, here the computer got virtualized. They bought servers, and inside of those servers, they created virtual machines. And on top of those virtual machines, they hosted their services like DSCP, FTP, TFTP, DNS, anything service, application service, web hosting service, and they are running fine. Okay, but they are facing one networking issue. So, what would be that networking issue? The routers are waiting outside for routing, correct? Because your routers are physical. So, whenever if one machine wants to communicate to another machine, that time what will happen? The traffic will go outside, routing decision will happen, and then will come back. For example, you are having two type of virtual machine, black virtual machine and you have red virtual machine. Black virtual machine is there in virtual machine VM10. Okay. Black virtual machines are having VLAN 10 and red virtual machines are having VLAN 20. Okay. They have their own switches, logical switches. They are connecting to their respective switches. How they are going to connect, I'm going to explain. This is not the this is not the short discussion. This is only explanation today. I'm going to just only explain you that how, what is the difference between legacy and software defined networking. Then you will realize that whether you should continue or not continue, not to continue. Okay, if you think that you already knows this, then you can simply drop your class and then you can continue that I already knows about this. Okay, if you think that yeah, there is a something new which I am learning, then well and good, continue. Right. So here there are VLANs. Suppose black servers are, black VMs are VLAN in VLAN 10, red servers are there in VLAN 20. Obviously, black servers will go ahead and hit to their black SVI, and red servers will also follow the trunk and then he'll hit the red SVI. Correct. So now here routing will take place. If this virtual machine, let me zoom in. If virtual machine 1 wants to communicate to virtual machine 2, if black wants to communicate to red, then what would happen? The traffic will go outside and then it will come back and then communication will happen. Even though they are sitting on same box, there is a hairpinning is happening. Correct or not?
Yes, correct.
Yeah. Second scenario, if this blacks 1 wants to communicate to this black 3. Now, the switching concept is go ahead and broadcast within your environment and done. Okay, only 1 minute, guys. Let me check my UPS status. I'll come back. Okay, guys, I'm back. So here, if 1 wants to communicate to 3, then do we need to go outside? No, right? Because switching says that within switch, I'm going to broadcast, accept the received port, then broadcast will happen, then 1 will here within this device will communicate to 3. Okay, so these VMs are going to talk to each other within the box, but whenever it comes to talking between two subnets, then traffic has to leave the server, hit the your router, and then come back. So this is called as hairpinning. So keeping your networking in legacy is not a good deal. Correct or not?
Yes.
That's the reason you have to move to software defined networking. So take same scenario and now let's move to software defined networking. Okay, so I'm going to delete this one. Okay, so now I'm going to design the software defined networking path. So obviously your compute got virtualized already, so that will be those will be your servers. I'll take 3 servers. Okay. Then in software defined networking, you can use your old pattern of switches, Nexus switches, or you can go for ACI. So what is the difference between Nexus switches and ACI? Nexus are legacy and ACI is software defined, that is following software defined networking. So what is the difference between NSXT and ACI? That I'm going to show it later. But if you are having complete software defined networking design, then this is how your environment looks like. These are the small switches. Okay, these are called as spine and these are called as leaf switches. Okay, they are connected in this pattern. Okay, they are running ISIs in between. And who is building this configuration? You are going to make trunk, all these link trunk one by one by logging in? No, there is a controller who is sitting here and he is connected here. Actually that is there in cluster, but I'm going to draw only one. By sitting here, he is going to drive all the port configuration. So this is called as epic, and this is sitting in management and control plane. Okay, so management plane and control plane. What is this? I'll take separate session to understand management and control plane. Okay, you don't have to worry about this one. Then you guys are going to uplink your servers here to this one. You are going to do 2 uplinks, but I'll go for only one. Okay, so you are going to uplink your physical servers. That is again fine. Then you are going to have your virtual machines, web server, app server, or whatever. So like I'll take 2 black server, then 2 red servers. Okay, and then 1 green server. Same way, green will be here, green will be here, like this combination, right? We are going to have combination of servers. One will be in this VLAN and another will be in that VLAN. Okay, these servers will go ahead and connect to their respective. There will be a switch, only one switch. Okay, inside of this switch, you will have the port group. Port group, what is port group? I'll explain later. Okay, you will have port group, black port group, you will have red port group, and you will have green red port group. Okay, all are connecting to their respective port groups. This is tagged to 10, 20, and 30. Okay, so let me draw it. This will have VLAN number 10, VLAN number 20, and VLAN number 30. Okay, 30. So now here the question is, if 10 wants to communicate to 20, then earlier they used to go outside. But what's going to happen is we are going to bring the routing functionality here. Okay, and all will get connected to their respective interfaces. And then this router will help you to do the routing here. Do you think this is good? Hairpin is happening like this? No, right? Traffic is not going out of the box. Traffic is within the box and it's shifting, providing the routing to all 3 segments. Okay, so now the question is, what's about these VLANs, these VMs? If green wants to communicate to this red, then the traffic will come like this. Okay, and then it will hit to the red. So here bottleneck is going to happen. For example, let's take another example. If this green wants to communicate to this black, so how the traffic flow is, both they have to come to this first box, 1, 2, and 3. So do you think bottleneck is going to happen? This green wants to communicate to this black. Obviously, we need routing functionality. So in software-defined networking world, there are each one router is placed in all servers. That is called as logical router. And this is an instance. And the gateway will be only 1.1. Okay. This is called as distributed routing. The router is one, but it's distributed among all the servers, and it will provide routing functionality everywhere. If this green wants to communicate to this black, then the green will approach to his router, and then the router will do routing and it will connect to black. If this want to communicate to this one, then it will happen like this. So this is the routing will happen within the your servers, and you are going to see it when you do NSXT. Okay, so this way your routing or your switching already got virtualized, your routing also got virtualized. What's about firewall? Any question, guys, on routing?
No, sir.
No, right? Okay, so now the next is firewalling. Okay, so generally what happen, firewall sits in between two devices. Okay, so if you are having firewall, so you'll keep your firewall here, and then traffic will come from this interface and leave this interface, correct? So firewall is there in inline firewall will be there, that sits in middle of your path. So any traffic is coming in, it will come through one interface that will call as interface or zone, and then it will exit from the another interface. Okay, so what's about the protection between the black should not communicate to red? What we are doing in legacy? Any idea? Any idea, guys, what we are doing to protect the communication between the VMs, between the servers? The firewall is protecting here. What's about the protection within the among the servers? If you have 80 servers and 80 is getting huge amount of traffic, though it's broadcast in nature, other servers are also listening to that traffic. They should not listen to that traffic. So what is the solution for that in
We
legacy?
can create VLANs in the server.
Which VLAN?
Multiple VLAN interface. We create VLAN interface in the server.
If you have 100 servers, then you will create 100 VLANs for each server. So we have solution in legacy that is called as private VLAN. Have you heard about private VLAN? Private VLAN
Yes.
is a concept. Private VLAN is a concept which will restrict the traffic between two devices within same VLAN. Okay, there is a community, and then the promiscuous port will be there. All these are that is a technology which will help you to do that. Okay, if you want to protect traffic between two black servers, then you can configure them in isolated port.
Sir,
Okay,
one question.
yeah,
Is this happening like port isolation, right?
yeah, port isolation and all, but that is legacy, right?
Okay.
But here you don't have to do it. Okay, because you are going to have a firewall here on top of your NIC. Each virtual machine is going to get a firewall. Like if you are going outside somewhere, suppose you are going to hospital, for example. Okay, so directly you'll take appointment, right? You'll call from here and check whether the clinic is open or not, right? So you'll get idea whether to go outside or not to go outside. If they say that doctor is not available, then will you go and then knock the door and check if doctor is available or not, and then come back? Got my point?
Yes, got it.
If you want to go to any of outside shop, okay, you'll call to that shop and check if the shop is open. If open, then you will travel. Otherwise, you'll sit here only. Same way, any virtual machine, if he wants to go outside, like internet, then he will check his firewall table whether I am allowed to go outside to access internet. If yes, then only I am going to travel outside. Otherwise, I am not going to block the road. Okay, so this is called as DFW firewall. This is called as DFW firewalling. And this is applied on NIC card. NIC card means your laptop is having NIC cards, right? Network cards. So there it's applied. So security starts from this point, your server level itself. Your server is having one firewall. That is not effective, right? Every operating system is having firewall. Is that effective? Somewhat is effective, but we are not configuring that much level. We are having Windows Defender and Windows firewalls. Generally, we are turning them off. Okay. So here, after the Windows firewall, there is another firewall on the NIC card itself. So that is called as the distributed firewall. First layer of firewall. Then here, another layer of firewall. One more layer of firewall will be there. This is second layer of firewall. If you are going outside, then there is one more router you have to pass through, that is called as T0. Then third layer of firewall. Then you'll go outside. Before this, IPS or IDS will be there. Fourth layer of firewall. And here, how many firewalls you are seeing? You are seeing only your firewall, and then you are having IPS and IDS. Here you are getting 2 layers of firewalls, and here you are getting more layers of firewalls. Okay. So for routing, hairpinning, it's not required. It's happening within the environment. Okay. For example, now you need load balancer. For load balancer, you have to purchase another system in your environment. But now I'll not go for that. Simply I'll have load balancer here only as a virtual machine. It will take minutes for me to deploy the load balancer. Okay. So previously NSXT was providing the load balancing functionality, but now it's been taken over by Broadcom. So now they have introduced the advanced load balancer, and they are discontinuing the legacy load balancer. Okay. So that is called as AVI, advanced load balancer. So what advanced load balancer will do? Advanced load balancer will go ahead and sit as a virtual machine here only. If any traffic is coming, then it will come to the load balancer, and then load balancer will give it to your node. Okay. So these are the mechanism. This is called as LB, load balancer. So you have firewall, you have the switches, you have routers, everything is there. So who is going to do this? This will be done by one device called as NSX manager. This manager, by sitting here, which is nothing but a virtual machine inside here only. If you see where this device is nothing but a virtual machine. NSXT manager is nothing but a virtual machine. Physically, it's sitting on top of this server, but logically, it's maintaining your whole environment. It's controlling your whole environment. Got it? And this router will check how many routers you need. Here you have to simply give the instruction. It will go ahead and deploy that router for you. You don't have to deploy as a virtual machine. So have you heard about the ASAV, guys? Anyone? Pradeep, Fazal, Imran, ASAV. So Priyanka has shift, so she's gone now. Have you heard ASAV?
Yes, sir.
So what is ASAV? A virtual appliance, virtual machine based firewall. Correct?
Virtual firewall is there.
Virtual firewall. So let's go to your legacy environment and let's have the virtual firewall. Okay. And let's ask everyone to give traffic here, and then it will go and give outside. So what's going to happen? This part, your hairpinning is avoided. Correct? You can avoid the hairpinning by configuring the ASAV inside of your box as a virtual machine. Correct or not? All VMs will act, the ASAV will act as a gateway, and then gateway will do the routing between two red and black. Correct? But here it's avoiding the hairpinning, but it's again creating the bottleneck. What is bottleneck? If this VM wants to communicate to this red VM, then again they have only one ASAV, so they have to come to this box only to ask the question. Right? So all devices, they have to come here only. So here bottleneck is going to happen. To make the decision, all will come here only. Okay, so they are having less traffic, but this device is getting more traffic. That's the reason the ASAV solution is not perfect. And this is looking clean, right? So this solution is perfect here. So this is called a software defined networking. If you go beyond the boundary, Now you are having this software defined networking. See, generally how many ways are there to approach the router? First one, how you are accessing Raju, your router? Raju left. Fazal, how you are accessing your router? CLI.
Yeah, CLI.
Then GUI. Cisco is not giving option, but GUI is one more option. Okay, then any other option? Imran sir. So there is a third option called as API. Okay, there is a one more option called as API, which Cisco will not give it to you. Because Cisco is running their legacy operating system. Okay, so there is a concept called API. With the help of API, you don't need to log in through CLI and GUI. What you can do, you can write a script and then you can, with the help of API, you can drive it. So what does that mean? I'll give one best example. Like suppose you want to order something. Okay, so what you are doing? First, you can go to your nearest hotel, that is CLI or GUI. You have to walk in towards your hotel. That is first thing. What is the second method you have? Any option available, Imran sir, to order food? है क्या इमरान सर? प्रदीप?
हाँ सर, नहीं पता ये.
Yeah, what is the option? Suppose I give you task to order something food from your nearest hotel. So how you'll order? First, you'll go walk by walk-in and then you'll order. Second,
By Swiggy.
Swiggy, right? What Swiggy is doing? Swiggy is making API calls towards that hotel, right? That is the second option. So what you'll do? Because second thing is you'll call to hotel. Second thing, because every hotel will not have that Swiggy option, right? That advanced option. First thing is you go by walk-in. Second thing is you can call to that hotel and then you can make decision. You'll call to that guy and then you'll place your order. He will explain something that he's having these many things available. Then you'll choose something and then you'll place order. Second thing. What is third thing? Third thing is by using your mobile. That is API call. Okay, so who is doing through mobile? Those systems are working. So that API call is something through Terraform. Okay, so first thing is you'll go by walk-in. Second thing is you'll call, that is API call. Okay, you'll call to hotel. Same way here you are going to call to router. That this router, how many interface you have? Then this router will say I have one black interface, one red interface, and one green interface. That is called as API call. Okay, then in API call you will say that shut down your wheel. Okay, the third method is through Swiggy. What Swiggy is doing? Swiggy is going to place one their agent or called as one tab or one system computer on that at that shop. Okay, they'll place that shop and then they'll ask that shop owner that you drive this one and through this you are going to get the order. So whenever you are placing any order, then it's popping up on the counter at the counter, and then the owner is going to accept the order or reject the order. Once he accepted, then he's going to prepare that food, and once food is prepared, Swiggy will be informed, and Swiggy one person will come and then he will pick up the package and then he will deliver it to you. This is how flow is happening, right? Same applies here. Now Terraform is coming in between, Ansible is coming in between. So what Terraform and Ansible is doing, Terraform will go to the vendor like VMware, say that I will go ahead and virtualize your environment. You do let me know how we are going to talk to each other. So Terraform say that, yeah, we'll talk in this language. Terraform is having one language. So if I say in this language something to you, you go ahead and form the BGP. Okay, so this is how it's working. I'll show you. Till now you work on what you call, you work on the Cisco IOS where you used to take the help command, right? Terraform So generally, how you form the BGP, OSPF, and all these things. So this Terraform will go to, this is going to the NSX, and NSX, if you want to have a router, if you want to configure interface. So generally what we need for interface, we need a gateway IP, right? So you put this command, your interface will be created. Green interface, black interface, whatever. You go ahead and give the name. If you, I'll give one small example. If you want to create load balancer, you can create it. If you want to configure BGP, where is BGP? Okay, if you want to configure BGP, do this configuration, your BGP is configured. So this scripting and all these things are happening. Neighbor, password, hold your timers, everything. Your BFD. Okay, if you want to configure any access list, you can go ahead and do it. So if you throw this code towards your router, your router is going to configure that BGP neighbor with that. So that is called as Terraform, or this is called as scripting. Okay, guys. So your routers are going to listen to you in multiple ways, through CLI, through GUI, through API, and another one is there under API, Terraform, Ansible, PowerShell. These are the language. Whichever is suitable, go ahead and take it. You can go ahead and virtualize your environment. If you want to create a router, any interface, what you do in your physical environment, you go ahead, you what you call log in, and then you create the interface, and then you do it. So that's it today. This is how the software defined networking works. So whatever the next is, I'm going to explain in next session. Any question, guys?
When we are pushing the configuration from the Terraform, first we need to onboard the devices, right?
You have to make such arrangement, then only you are going to push it. You won't be able to push to your Cisco routers Terraform, because Cisco is not supporting that, right? Second, you have to make such arrangements. Whatever arrangements is there, I'll explain you Terraform. Okay, guys, any question before wrapping it up? Today is something introductory session only. Okay, I'll share this recording to you guys. Thank you. I'm going to stop it. If you have any question, be there on call. I'll answer. Otherwise, you can drop off.